Hello, here is the review portion for the semester final for the linear functions part that is given to you. So it starts with question 8 in your review packet. First question says, find the slope of each line described below. So I wrote some key things kind of on the bottom to remember about slope. Sometimes we think about it as rise over run. Sometimes we think about it as change in y over change in x. Sometimes we use this formula, y2 minus y1 over x2 minus x1. Those all can help us find slope. So if I'm going to do it for A, I like to use the formula. So I'm going to do this as my x1, y1. So the first pair is my x1, y1, and my second one is x2, y2. So I'm going to have negative 1 minus 5 over 4 minus negative 3. And then I am going to simplify, so I end up with negative 6 over 7. Okay, let's look at B. It says parallel to y equals 1/5 plus 3/5 x. Well, parallel means that we have the same slope. If the slope is 3/5 here, my new slope is still going to be 3/5. For C, it wants to be perpendicular to y equals 1/5 plus 3/5 x. So again, we're looking at that slope of 3/5. If our new slope, m, is going to be perpendicular, it has to be the opposite, so it's going to be negative, and the reciprocal, so it's going to become 5/3. For each line below, identify if its slope is positive, negative, 0, or undefined. So when I look at A, it's a flat line. I know like if I'm skiing, I'm not going anywhere. That is a slope of 0. It's my horizontal line. My next one, B, the line is going up from left to right, so that one is positive. C is going down from left to right, so it's negative. And then D is vertical, straight up and down, and I know that one is undefined. Remember, you have some things like Vuxhoy to help you remember your special slopes with being undefined and 0. Okay, 10 says write an equation for each line graph below. So since we're given a graph, and we can see our lines, I chose to write my equations in slope-intercept form because we know our intercept, our b, it's our y-intercept. We can get that right from our graph, and we can get our slope. So once we find them from our graph, we just have to write it. So for A, here's my y-intercept right where it crosses there, so my b is 1, my slope. Here, I think I used this point and the point right there, so you had to go down 2 and over 2, so it's negative 2 over 2, which is negative 1. So then my equation was y is equal to negative 1x plus 1. For my next one, you can see my b is negative 1. My slope is, I think I used this point right there, so I went up 1, 2, and over 1, 2, 3, so 2/3. Equation is y is equal to 2/3 x minus 1. And our last one, it looks like the y-intercept goes through 0. And slope, I think I went down 1 over 1, 2, 3, so negative 1/3. So my equation was y equals negative 1/3 x. And then you can add on the plus 0 if you want to, but it doesn't change anything. Alright, 11 says write an equation in point-slope form which meets the given conditions. So here's point-slope form, y minus y1 equals m times x minus x1. Let's look at A first. It gives us our m, says it's a third, and then it gives us our ordered pair. Our x1, y1 is 2, negative 5. So we're just going to plug it in from there. So I have I'd have minus a negative 5 is equal to our m, so 1/3 x minus 2. And then a lot of you are like, wait a second, should we go back and change that? Yeah, that'd become y plus 5. So if you want to erase that one there, you're good. B says passes through 3, 6 and 5, 2. So 3, 6, 5, 2. Some of you guys like to use the bar method also for slope. So to get from 6 to 2, if I'm finding my slope, would be negative 4. 3 to 5 would be 2, so my slope is negative 2. Rewrite that a little clearer there, sorry. And then I need an x1, y1. It doesn't matter which one you go with, so I'm just going to pick the first one and call that x1, y1. So my equation is y minus 6 is equal to negative 2, x minus 3. Okay, and then for C, it says passes through negative 1, negative 3, and it's parallel to y equals 7 minus 5x. Well, if it's parallel, it's going to have the same slope, so my slope's going to stay negative 5. So m is going to equal negative 5. And then I have my point, negative 1, negative 3. Again, it's a little sloppy, sorry. Working on the iPad. So I can write my formula. So it's going to turn into y. I'd have y minus a negative 3, so it's going to become y plus 3. So equal to negative 5, x, and then it's x minus x1. Well, I'm going to have minus a negative 1, so it's going to turn into a plus 1. All right, 12, we have Stanley. He is working. He's trying to keep track of the time it takes to assemble some sandwiches, and his line was graphed, or his data was graphed to the right. I sketched a trend line in. It's obviously kind of hard to do it straight on my iPad. You could do this with a ruler or a book or something, but you draw a line straight through the data as close as you can get to all of the data points. And then we're going to predict how long it takes him to assemble 12 sandwiches. So 12, you'd follow it up from your x-axis. So I followed up. And then I would go over, I would say anywhere around 10 minutes is an acceptable answer. So 9, 10, 11, anywhere in that range would be good. Okay, 13 says match each equation on the left with its equivalent equation on the right. So A is in point slope form. It says y minus 3 is equal to 2 times x plus 4. If I have to match it with one on the right, those are both in slope intercept form. I need to solve for y. So I'm going to distribute that 2 first, and I get y minus 3 is equal to 2x plus 8, and then I would add 3. So y is equal to 2x plus 11. So that's the one matching there. For B, I have 2x plus 3y is equal to 12. I'm in standard form, still solving for y, so subtract 2x. So I have 3y is equal to 12 minus 2x, and then divide by 3. So y is equal to 4 minus 2 thirds x. And it looks like this one is a match. And then for C, let's fix that. I have a fraction again. It's not in a specific form really. It's closest to slope intercept, but we still have to distribute that 2/3 through. So I get y is equal to, well, 2/3 x. Then you have to do 2/3 of negative 12. So I do 2 times negative 12 is negative 24, and then divide by 3. So minus 8 plus 1. So if you want to think about that, it's 2/3 times negative 12 over 1. So I got negative 24 over 3, which is how I got negative 8. So then y is equal to 2/3 x, combine like terms, minus 7. For the last one, it says determine if each table shows a linear relationship. Linear relationship means that there is a constant change, so you need to check your change in y over your change in x. So if you remember doing this before, we would draw little kind of loops here and check each one. So x is going up by 1 every single time. And my y's are, it looks like, going down by 30. So it's constant. It looks like I'm always doing negative 30 over 1 every single interval. So this one would be a linear function. Let's look at B. I'm going to erase some of this so I have room here. Again, x's are going up by 1. That makes this change in x part here easy. So at first it looks like I go down 30. And then right away in the second one, I can see I don't go down 30 again, because if I did, I'd be at 60. That can't be linear because it changed. So not a linear function. And then let's check our last one. X's are still going up by 1, so let's check our y's. 120 to 180 is plus 60. 180 to 270, well, that's plus 90. So already, if this is a plus 1 and this is a plus 1, I had a slope of 60 over 1, which is 60, and then 90 over 1. Not the same. So that is not a linear function. So this was, again, the linear functions portion of the review packet. If you need to see some other solutions or answers, check out some of the other videos on my webpage. Thanks.